access and reduce network load, we can cache our observables. Welcome back to Rxjs and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and in this module we cache our observables to share our streams. This is a DVR or digital video recorder. You may have used one of these to record movies or shows. A DVR allows you to download digital media and retain it locally, so when you want to watch it, you have it ready. No need to wait for it to download. And if you watch the same content again, it replays the downloaded copy. Caching observables follows the same principles. Caching is the process of retaining retrieved data locally, so future requests for that data are served faster without retrieving the data from the back-end server. Caching allows us to efficiently reuse previously retrieved data. Cached data can be stored in memory at runtime or stored external from the application. In this course, we implement runtime-only caching, so the cached data is gone when the user exits the application. In this module, we start with the why, then move to the how and walk through patterns for data caching. The Rxjs features covered in this module include Share Replay. Let's get started.
JavaScript and updates variables. Next, adding on quick content. I click the button and have my content show up.
Whether we follow the classic pattern and retrieve in our ng-aninit method, or use the async pipe and retrieve when the page is displayed, we retrieve the data every time the user navigates to the page. Let's see that in action. Bring up the browser and open the developer tools. Let's refresh the application. Then click the product list option. Notice the bit of delay as the application submits the HTTP request, collects the data from the backend server, transfers that data down the wire, and maps it to our desired shape. We're mocking this process in our sample application, but these types of delays exist in real-world applications. When our data is retrieved, the tab operators we added to the HTTP GET observables log that data to the console. Now click Home and click Product List again. Notice the delay as we again retrieve all the product data and see it logged to the console again. If you are building a highly transaction-based application, like flight reservations or movie tickets, you may want to always get fresh data, but often data doesn't change that frequently. In our sample application, our company's product list changes seldom. And some data, like product categories, change even less. Let's consider caching the data for our application in our service. Caching data in the service has several advantages. It improves responsiveness. If we cache the retrieved data in the service, the next time the user navigates to the page, the data is available and ready for display, improving performance. Caching reduces bandwidth and network consumption. This is especially helpful for users with bandwidth-restricted devices or slow networks. It reduces back-end server load. Caching retrieved data in the service minimizes the number of server requests for that data. And caching reduces redundant computations. If we pipe emitted items through a set of calculations or transformations, we can cache the result so we don't have to repeat the operations. Now that we know the why, let's look at the how. One classic pattern for caching is to define a property to hold the data in the service, then define a method that returns the cached data or issues an HTTP GET request to get the data. This technique works, but it's not very declarative. A more declarative approach uses the reactive programming pattern we've covered in this course and pipes the observable through the Share Replay operator. This caches and shares the resulting observable. How does that work? Share Replay shares the stream with other subscribers and replays the defined number of emissions on subscription. In this example, it replays the last emission. Share Replay is used for caching data in the application. Let's look at the marble diagram. Here is the source observable. We use interval to emit a number every 1,000 milliseconds. Take only 3 numbers and specify a share replay buffer of 1. This line represents the share replay buffer. The first subscriber starts the source stream. The source stream emits 0, which is buffered and emitted to the first observer. Then the source stream emits 1. Since the replay buffer is set to a maximum of 1 item, the 1 replaces the 0 in the buffer. At this point, another subscriber subscribes, and the buffer is replayed, emitting a 1 to the second observer. When the source stream emits 2, it replaces the 1 in the buffer, and it's emitted to the 2 observers. Since we've now taken 3 emissions, the stream completes. Even though the stream is stopped and won't emit any more items, if a third subscriber subscribes at this point, the buffer is replayed, emitting a 2 to the last observer. More formally, share replay is a multicast operator. It returns a subject that shares a single subscription to the underlying source. It takes in an optional buffer size, which is the item count of the replay buffer. This is the number of items that are cached and replayed for each subscriber. On a subscribe, it replays the specified number of emissions. The items stay cached forever, even after there are no more subscribers. Let's try it out.
jQuery is register and deregister listeners. So you can see my listeners on and off. When it's on, I run my mouse and my div. It changes colors. It goes to a random color every time I move. I can turn it off.
In this demo, we cache data at runtime using share replay. Let's start by bringing up the browser and looking again at the console. Refresh and look at our logging. We see that we retrieve the categories, then the products, then the categories again. It looks like we're getting the categories numerous times. Let's try out share replay with the categories first. Once again, we're in VS Code with the APM folder open. Here in the product list component, our products dollar stream combines a data stream and an action stream. The data stream is products with add dollar. Using go to definition, we see that products with add dollar merges products with category dollar and our product inserted action dollar stream. Using go to definition again, we see that products with category dollar accesses the product categories dollar stream. Using go to definition one more time, we see the HTTP GET, and this is the tap that logs the first categories message in the console. Going back to the product list component, we also use the product categories dollar stream here to populate the filter box. That's what causes our second categories message in the console. To share the retrieved set of categories, let's use share replay. In the product categories service, let's add share replay after the tap and before the catch error. We'll specify a buffer size of 1 and add the needed import. Is a buffer size of 1 enough? Recall that the HTTP GET returns an observable that emits a single item, the array of product categories. That's the item we'll cache and replay. Back in the browser, refresh the product list. Notice in the console we now retrieve the categories 1 time. The next time they're needed, they are replayed and not re-retrieved from the server. Yay! Click Home and click Product List again. Our products are re-retrieved, but our categories are not. Even when the product list page was destroyed, the shared observable remains and replays as needed. Now let's do the same for products. In the product service, there are several places we could cache the products. We could add the share replay here as part of the products dollar pipeline. That would ensure that the products were replayed instead of re-retrieved. But that means all the code that maps the product with its product category would still be re-executed on each subscription. We could instead add the share replay here. Then it replays the products with their categories, reducing redundant computations. Let's add share replay at the end of this pipeline. We again specify a buffer size of 1. We only need to replay the last emitted item, which is our array of products with the category ID mapped to a category string. And we add the needed import. Since several features of the application may share the selected product, let's add share replay there as well with a buffer size of 1. Let's see if it works. Bring up the browser, click Product List, and refresh. We retrieve the categories one time and the products. Click Home and Product List again. Wow, did you see how fast that page appeared? And no additional logging. Our streams replayed values they already retrieved, improving our application performance. Nice! Use Share Replay as needed to cache your streams. Let's finish up this module with a brief summary and some considerations when caching data.
In this module, we're going to take our understanding of the UI and how to work with it, and really start to do some neat stuff regarding creating dynamic user interfaces.
Use Share Replay on any stream you wish to share and replay to all new subscribers. But to prevent stale data, we need to consider cache invalidation. Cache invalidation is a way to clear the cache at some point and refetch the data. That way it doesn't become stale and tool to be useful. Here are some considerations. Evaluate the fluidity of the data. If the data doesn't change often, like product categories, caching is beneficial with minimal chance of stale data. But if the data does change often, such as hotel reservations, caching may not be a feasible option. Evaluate your user's behavior. Do they open the application, perform a task, and exit? Or do they keep the application open all day, every day? If the users exit often, you may not need any additional features to invalidate the cache. It's cleared when the user exits. Consider invalidating the cache after some time interval based on the data fluidity and application usage. For example, every 10 minutes or once an hour. Take care that you don't refresh the display with updated data while the user is working with that data. Consider allowing the user to control when the data is refreshed. Consider always getting fresh data on update operations to minimize an update to stale data. Now we're ready to tackle more complex operators for mapping higher order observables.